In this chapter section, we are going to take a look at organic functional groups. Functional groups are groups of atoms attached to the hydrocarbons, especially the alkane. And these functional groups will alter physical and chemical property of the alkanes or the hydrocarbon. And here are the list of the functional group. For example, when we talk about alcohol, R represent hydrocarbon and OH is the alcohol group that attached to the hydrocarbon. For example, you can recognize this alcohol group when it's attached to the hydrocarbon. And the next group is called ethers. Ether is when the hydrocarbon is attached to oxygen and attached to another chain of hydrocarbon. And as example here, right, so you have the hydrocarbon attached to oxygen and attached to another hydrocarbon. The next group is called aldehyde. Aldehyde have this general formula right here where the hydrocarbon is attached to C double bond OH. Okay, so or the condensed form would be CHO. Okay, so for example, hydrocarbon attached to C double bond OH. And you can see, right, if you're looking at all of these, pretty much all of these R group represent hydrocarbon, and each different functional group would have different structure. For example, ketone would be C double bond O. Carboxylic acid would be C double bond OH, and the acidity of this compound come from this hydrogen that attached to oxygen, because the oxygen will withdraw electron from hydrogen, make this bond to be very polarized, and is going to cause hydrogen to break off the bond easily, giving off acidic proton. The next group is ester. Ester is when you replace this carboxylic acid hydrogen with another hydrocarbon, right? So if you remove this, replace with hydrocarbon, that's what the you are going to get the ester. Amines is going to be the group where nitrogen is attached to the hydrocarbon, and these are in an amines can either be hydrocarbons or hydrogens. Okay, amines is the group that would behave as a base. Okay, so we see this before when we talk about acid and base, right? So pretty much carboxylic acid would behave as weak acid. Okay, and then amine would be a weak base. Okay, the reason for that is because amine, the nitrogen in the amine has the lone pair that can accept a proton. Therefore, amine functional group would be proton acceptor, which is the base. Okay. Another group is amide. Okay, so this is the structure of amide. So it's similar to ester, except you are replacing the OR group with the N with this amine group. So pretty much the amide is the result of the reaction between carboxylic acid and amines, and this is what you are going to get is the amide. Or if you are taking biology class, this type bond is what you know as the peptide bonds, or you are going to see this again if you are taking biochemistry. Okay, so this is the bond that found in protein, right? And the next type of functional group would be any hydrocarbon that attached to halide groups, group 7A, right? So fluorine, chlorine, bromine, and iodine, right? So this would be the halide group. And whenever that you see double bond or triple bond, or even the benzene ring, you should know that all of these would also make the chemical and physical property different from the alkane as well. Therefore, you will need to identify this as functional group as well. So you need to make sure you actually indicate those. Okay, so pretty much the goal of this chapter section is that you need to be able to recognize these functional group in an organic molecules. So what do I mean by that? Let's take a look at the next example. For example 1, determine functional groups in the following molecule. So in this case, for sure, what we recognize is the double bond. So this would be part of alkene, right? And we also recognize triple bond as well. This would be alkyne. Okay. The next thing is we are going to take a look at next. I'm not going to consider this as functional group because this is just hydrocarbon. Okay, so CH3 is just hydrocarbon. So I'm going to circle the next one, okay, which is not the hydrocarbon and it's not double bond or triple bond or aromatic ring, which is NH2. NH2 you will see that it's attached to the hydrocarbon, right? So this whole thing would consider to be hydrocarbon. This group, NH2, or the one that have nitrogen connected to the hydrocarbon, this group then would be called an amine. Okay, so this is the amine functional group. Okay, so another group that we see is the C double bond O that's connected to hydrocarbon on the left side and also hydrocarbon on the right side. These, if you go back to the table, you will see that this is the ketone functional group. Okay, and let's move to the next. Okay, so it's this one right here. I'm going to circle oxygen. Okay, this oxygen right here is connected to hydrocarbon on the left and also hydrocarbon on the right. Therefore, if you go back to the table of the functional groups, you will see that this is the ether group. Okay, and the last one is the element from group 7. So this is the halide functional group. Okay, so that means in this case, expected on the exam, you will be given a molecule like this, and then you will need to be able to identify each of those functional group. Okay, so let's take a look at the next one. Okay, so the next one, we recognize this structure, 6-member ring, have the alternate double bond. This is the aromatic ring. Or another name for this is the benzene ring. Okay, so either way it would be correct. Okay, the next one, we are going to take a look at the next part right here. So this part, you would observe the functional group where the carbon attached to double bond O, and then another one is not the, so this one right here of the carbon, okay, is attached to the bond O, but on the left side is not hydrocarbon, it's actually having the NH. Therefore, this whole part would be the same part, right? So I'm going to circle that, so it would be this part right here. Okay, and as you see, this group attached to hydrocarbon on the left and hydrocarbon on the right, this group C double bond O NH, this group would be called the peptide bond or the amide. Okay, last one. Okay, so last one we see OH that attached to hydrocarbon, right? So this is hydrocarbon. So this group, the OH group that attached to hydrocarbon, would be called alcohol. Okay, so this is the same functional group that is present in drinking alcohol, ethanol, right? So the reason why we call alcohol, because ethanol, molecule of ethanol, CH3, CH2OH, contain this functional group of alcohol. That's why in general term, we call this as alcohol, because ethanol, more specifically the drinking alcohol, contain the alcohol functional group or hydroxy group. If you are learning in biology, this group might be called a little bit different, right? It can be called hydroxyl group as well. Okay, but in this class, you can just stick with the word alcohol. All right, let's take a look at next one. Okay, so next one, I'm gonna go ahead looking at this one right here. Okay, so carbon, this carbon connected to double bond oxygen, and on this side is not hydrocarbon but is hydrogen. Okay, the other side is contain hydrocarbon, so this is hydrocarbon because contain carbon and hydrogen. Therefore, the functional group would include this part right here. C double bond O and have the hydrogen attached to, and then another side attached to hydrocarbon. This group is called an aldehyde. Okay, and again we see this one again. So oxygen attached to two side of the hydrocarbon. So this oxygen right here is an ether. Okay, and this group right here, oxygen and hydrogen attached to the rest of hydrocarbon, so this would be called alcohol. Okay, and again the 6-membered ring that have alternate double bond would be the benzene ring. Or aromatic ring. Okay, so let's take a look at next. Okay, so we're going to do it next one. So next one, we are going to do the same thing. Okay, so we recognize a group that is not carbon, right? So it's contain oxygen and hydrogen, and is the carbon attached to those. On the other side is contain hydrocarbon here. Therefore, in this case, we are going to cut functional group around this one right here, right? So because this part is the hydrocarbon part. So this group, if you look at the chart on the table in the previous page, you will see that this is the carboxylic acid. Okay, and the acidic proton would be this proton right here. So this proton is what we call acidic proton. Right, so that means in this case, this molecule in water is going to most likely to donate that hydrogen right there to water, because this molecule is a weak acid because it have acidic proton. Okay. Same thing for the next one. Okay, so the next one is going to be this part. Okay, the reason why I circle that, because this group right here on this side is connected to hydrocarbon, on this side also connected to hydrocarbon as well. C double bond O and connect to another oxygen that connected to hydrocarbon. This is what we call ester. This is an ester group. Okay, and the last one, the hydrocarbon that we have, this part right here is the aromatic ring, or the benzene ring. Again, it's the same thing. Okay, so this would be an example that you probably gonna see on the exam. It's gonna be giving you the molecules, and then you have to identify the functional group like this.